Good morning, all y'all. Class starts. Yeah, class starts in 5 minutes. Good morning, Michael. How are you guys doing? It's week 7. Week 7! We are... Yeah, this week is halfway there. How are you guys doing in terms of exams? Yeah, well, we all are. We are all missing spring break, which technically would have started after this week. Tears. But we're almost to the midterm for 2:30, which is a good transition, at least for 2:30. It breaks it up. I don't know about your other classes. Your other classes, it might feel like you're just continually being hit over the head with a rock. I don't know, what are your exam schedules like? How are you guys doing in terms of exams? It is midterm season. You guys are very chatty today. Let's see how many people we have. Oh. There's only 9 of you. So... A. Schwartzmeyer, mostly at the end of the month. So do you have them all like stacked on top of each other? Oof, that's unfortunate. Midterm, chem quiz, physics test, and a calc test. So in the next 2 weeks. Morning Ryan, morning MTM. So, Michael, it sounds like yours all are all over the... So, yeah, I guess it depends on what you're taking and what year you are. Okay, interesting. It sounds like you guys are all over the place. 327, 329, 43. Ooh. So you have one on 326, 27, and 29? Ah, I'm so sorry. That sounds like a lot to manage. It's so interesting because this morning I asked, is like the fact that our midterm is after week 9 helpful to spread things out? And some people were like, yeah, it's super helpful. And you guys are like, nope, everything's stacked on top of each other. It'd be interesting. And I know in an institution this size, you can't have everything standardized, but it'd be interesting if we could get all the instructors on like a specific schedule. In my 240 class, I have quizzes every 2 weeks instead of a midterm, and I actually kind of really like that structure because there's not like one big thing that's looming over everybody. I don't know. Maybe students like it, maybe they don't. Anyway, good luck on everything you guys have coming up. Okay, so Flora, you ask a really good question. I'm gonna go ahead and start talking about the midterm. So the midterm is coming up on 3/27, so March 27th. It's a little less than 2 weeks, so it's 2 full calendar, like mid-work weeks, I guess school weeks away. But it's 3/27. So Saturday, March 27th at noon. It will be an hour and a half or 2 hours, one of those. And it's going to be on UB Learns. So you will sit down at your computer, you'll pull up UB Learns, you'll be presented with a bunch of questions. You will have to program them in MATLAB. So you're essentially going to be writing a bunch of different little MATLAB scripts. I don't know what all the questions look like right now, because we haven't fully written it yet. I will have more information, hopefully on Friday. But that's what it's going to be like. You're going to be writing a bunch of little small programs. I've had questions on what to study, what to do for the exam, and my recommendation for you guys right now is to just do your homework. Don't worry too much about studying. Focus on the homework. The set of material that we are going over this week is very important. It's very important that you guys understand it, that you guys know it for the exam and for the project moving forward. So don't worry too much about studying too heavily. Worry more about doing your homework, making sure you really understand this loop material. So you will not have Respondus browser. You'll be proctored on Zoom. So you'll join your Zoom call. It'll be broken up. It'll be either a TA or an instructor doing the proctoring, and you will be recorded. So you'll have essentially like probably your phone or something that shows you in your work environment. You will have access to anything really you want except for other people. So you can use your textbook, you can use MATLAB help, you can use anything within MATLAB, you can use the internet, all of that fun stuff, just not other people. But you'll have access to pretty much anything you want. So like I said, for studying right now, do your homework. Focus on doing your homework because this material builds on itself. In order to understand loops, you're going to need to know that there's going to be some branching in there. In order to do branching, there's also going to be some, not in order to do branching, but for this homework, there's going to also be some branching. There's also going to be some input-output, and then all of the array stuff we learned previously. So make sure you're focusing on this material that we're learning this week. Yes, you can have Zybooks open, anything you want. You'll be timed. You'll have a limited amount of time. So you'll write up little programs, submit all of those M files. So make sure you're familiar with your MATLAB and everything you've been doing for your homeworks. If you do want to practice some stuff, maybe go back and do some more challenge activities. Go back and do the challenge activities you've already done. I don't know if Zybooks saves your responses for the challenge activities, but go back and try some more challenge activities. You'll find that either it's easier than the first time you did it, or it's an area you might need to focus on more. That's my suggestion for this week. Next week, we will finish up our MATLAB material. So next week we're going to finish up our MATLAB material. I'm going to talk about plotting on Monday. Wednesday I will do exam review, and then Friday I will have some extra office hours as well. Don't worry too much about being timed. Worry more about how can I demonstrate that I know what I'm doing. Given a problem, identifying, okay, and I'll talk about this next week, but what are the structures I need to have? Add in some comments. You're not going to have MATLAB grader for this, so you're not going to be able to check if you got the right answer. But I mean, they're short answers. They're going to be manually graded, so it's not all or none. So I don't know. You will get a review material. Like I said, I will have a lot of that beginning next week. So right now, don't worry too much about the exam. Worry more about understanding loops and this material for this week, because it's very key. It's very important material. Okay, let's go ahead and get started. So this week we are talking about loops. We are talking about repetition, repeating code over and over and over and over and over again until a specific condition is met. So I'm going to go over as many examples as I can this week. Like I said, this is key material. Loops is the last programming concept that we're going to go over that applies to pretty much all programming languages. We still have plotting, but really we're almost done with the MATLAB material. Loops tend to be a little more challenging for students. I forgot to change my header again. Loops tend to be a little bit more challenging for students. I should just take it out. Oh well. Loops tend to be a little bit more challenging for students just because it's not linear per se. It's not top to bottom. Now we have this section of code that we're going to repeat. So we're going to loop in our program. We're going to check to see if something's true, do some code, check to see if something's true, do some code, check to see if something's true, do some code. So it's not top to bottom anymore. It's top to bottom with some loop-de-loops inside and moving forward. So it's not hard conceptually for students to understand. It's just in practice. Okay, so let's go ahead and get to some practicing. So first thing I'm going to do, write a loop that displays numbers 1 through 20. So here's my first loop. It's just going to be very basic. We already know how to do this with the display function, so I could just say display 1 through 20. And it would just display all of my numbers. And displays it like this because it's not a column. So if I transpose this, there we go. It just displays numbers 1 through 20. Okay, so I can do this in one line of code. MATLAB allows me to do that. But I want to do it with a loop. So when you're writing loops, there's a couple things that you want to identify. So the first thing is identify the purpose of your loop. So what exactly is your loop going to repeat? What code do you want to repeat over and over and over and over and over again? For this loop, I'm going to display a number over and over and over again. So I want to display a number. That's the purpose of my loop. Display a number. And then identify what type of loop you want. So a while loop or a for loop. I'm going to demonstrate both. So I'm going to start with a while loop. Make sure everything is indented properly. So to indent, you just click Control A, highlight everything, and then Control I. Or in the editor tab, there's also an indent button that allows you to indent everything appropriately as well, just like comment, block comment. Okay. So this is the code I'm repeating over and over again. Display num. And then a while loop or a for loop. So I'm going to illustrate both, a while loop, and then I'll do a for loop. Okay, so when you're writing a while loop, we have something called a loop control variable. It's the variable that is going to change throughout my loop. It's the variable that's going to identify when my loop is going to end. It's just a variable that is going to be initialized, tested, and modified. The only variable I have in here right now is num. So let's just say I'm starting with num. So first things first, given that variable, I need to initialize it. I need to come up with some initial value. And I'm going to start it at 1 because I'm displaying numbers 1 through 20. So I'm just going to start out with num equals 1. That's a good starting number, right? It's a good starting number. Num is 1. Okay, so num equals 1. That's my first number. It's initialized before my while loop. Then I need to determine when I want my loop to stop, when I want num to stop changing. So it's written in your notes. There's this whole section in your notes that identifies essentially these steps I'm talking about. So determine the purpose, and then these are specifically for while loops. So initialize your variable. In this instance, I'm initializing num. Then what I'm going to do is determine my termination condition. So when do I want it to stop? What is my last value of num I want to have? What identifies when I am done going through this loop? So for this loop, for this example, come on. For this example, I'm done when num passes 20. So when num equals 20 is my last value, so I'm done essentially when num is greater than 20. So that's when I'm done. I'm done when num is greater than 20. Because I've gotten to 20 and then I'm done. So what I'm going to do is I'm going to invert that statement. So I am going to invert it to identify when I want my loop to continue. So inverting it is going to be num less than or equal to 20. So that goes here. That's my conditional. So this identifies when I want my loop to stop or when I want my loop to continue. So it identifies two things. It's going to continue while num is less than or equal to 20. It's going to stop when num is greater than 20. So it helps to think about when you want to stop and then invert it to think about when you want to continue. And it's pretty straightforward for this basic loop, but it'll get more complicated given different examples. So my third thing then is I'm going to modify my variable. So this is done inside of my loop, so between the while and the end. Inside of my loop, typically at the end of your loop, not always, but typically at the end of your loop, you're going to identify how you want n to change. So if n starts at 1, then I want it to be 2, then I want it to be 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, etc., all the way down to 20. So that essentially I'm adding 1 each time. So num equals num plus 1. So loops do not have the word loop in it. So a switch or if statement, those are branching statements. The generic word for if and switch is branching. The generic word for while and for is loops. So you have while loops and you have for loops. In other languages, you have other types of loops, but in MATLAB, we have while loops and for loops. So we have a while keyword and a for keyword. That's a good question. Okay, so here's my loop. Num starts out at a value of 1. While num is less than or equal to 20, I'm going to repeat this code over and over again. So let's go ahead and step through this one at a time. And I want us to pay attention to my variables. Okay, so first thing is num equals 1. So now in my workspace, num has a value of 1. I hit my while loop. Num less than or equal to 20. 1 is less than or equal to 20, so that means I'm going to execute the code inside. So I display num, it displays my 1, and then num equals 2 now. So then I'm going to go back up to my conditional, and now I'm going to check is my new value of num less than or equal to 20. 2 is less than or equal to 20, so I'm going to execute the code inside. Display my new value, and then change it. So now num is 2 plus 1, or 3. Then I go back up, 3 is still less than or equal to 20, so I'm going to execute the code inside, displays my 3, num is now 4. Go back up, 4 is still less than or equal to 20, display that 4, now num is 5. And it keeps going through this one at a time. Num is 14, 15, 16, 17, 18, 19. So here we're at 19. So hopefully Danya Hannon, hopefully this illustrates that. So num is now 19. So I'm going to display 19 and then it's going to go to 20. So I've gone through with 20. It's going to go back, or I've gone through with 19. Num is now 20. Going to go back up. 20 is still less than or equal to 20. So I'm going to execute the loop. So print out the value of 20, print out 21, or not print out 21. Now num is 21. Then I'm going to go back up. 21 is not less than or equal to 20. So I'm going to exit. So Dan, your question, num is going to be 21 at the end of my loop, but I'm only displaying 1 through 20 because num goes to 21 at the end. So when I go back up to check here with 21, this is going to be false, and that's going to trigger my exiting number. So here in my command window, you can see I'm printing out 1 through 20. Yeah. Okay, so like I said, we have num here. Num is our loop control variable. So our initialization, testing, and modification. All of these 3 things make a difference. So if num started out at a value of 100, if num starts out at 100, I hit my while loop. 100 is not less than or equal to 20. So it's not even gonna go inside my loop. It's gonna skip over everything inside of it. So it's not even gonna go inside my loop. So our initial number matters. If num was -10, then I start out -10. So -10 is less than or equal to 20, display -10, goes to -9. Display -9, goes to -8. Display -8, goes to -7, etc. So now if num is -10, I'm gonna print out numbers -10 through 20. So our initialization matters. If num started out at 0, I would print out 0 through 20, given this setup. So our initialization number matters. Our testing matters. So if I had num greater than 20, then this is an incorrect test. I wouldn't print out anything because 1 is not greater than 20. So our testing matters. This is going to be identifying when we're going to stop. Is there a way to all of the terms leading up to the maximum value rather than individually? Nick, I think you're missing a word in there. Also, if our modification, so if I did num equals num plus 2, it would print out only my odd numbers. So 1, 3, 5, 7, 9. If I printed out num equals num plus 0.5, it would print out all of my... There you go. It would print out all of my half numbers as well. So is there a way to calculate the value for all the terms? Calculate what value? Like if you wanted to calculate the sum of all the values? Sure, there's a way to do that. We'll talk about that on Wednesday. I have an example on Wednesday for that. You can do whatever you want inside your loop. This is just a basic counting loop that I'm just demonstrating. Okay, so the way we modify our loop matters. If we didn't have this modification, this is what happens. Notice in my command window, it's just printing out 1 every single time because num never changes. So num is 1, displays num. Num is 1, displays num. Num is 1, displays num. It never modifies this. This never changes. This answer never changes. This is called an infinite loop. If you ever run into that, press Control-C. Control-C, that's true for Mac users as well. It's the control button, not the command button. So Control-C, that will end your program. It will stop whatever MATLAB's doing early and just be done. That's true if you're like using the input function as well. If you ever want to just exit your code and just be done with it, then you just press Control-C. So all of these 3 things matter. Oops. All those 3 things matter. Okay, so that's what it looks like in a while loop. If I wanted to do this with for loop, it's a little bit different. It does the same thing, it's a little different. I'm still gonna repeat the same thing. I'm still displaying num. So notice this is still the same. I'm still displaying num. For a for loop though, you would just have your loop index variable, which in this case would be num, and you're just identifying what are all the values of num that you want. So I want num to start at 1, and I want it to end at 20. So we just say for num equals 1 to 20. So num here now is called a loop index variable versus a loop control variable. And what it's going to do is num is not equal to an array. Num is a scalar. I harped on that a little bit in the videos. Num is a scalar that's going to be equal to these values, 1 at a time. So let me comment this out and step through this one. So through our for loop. So num starts out at a value of 1. You can see that in my workspace. Num is 1. It's the first number that's listed out here. It's the first number in this group. It's going to display that. And then num goes to 2. So notice it went to 2. It grabbed the second number in this collection. And then num goes to 3. It grabbed the third number in this collection. And then it goes to 4, and then 5, and then 6, and then 7, then 8, then 9, then 10, all the way until 20. So when it hits 17, 18, 19, 20, and then it's done because it runs out of numbers. So even though this is what this array looks like, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through 20. Num is a scalar. It's going to grab the numbers in this array one at a time. So first it's 1, then it's 2, then it's 3, then it's 4, then it's 5, then it's 6, then it's 7, 8, 9, 10, etc. So this is a scalar that changes value based on the numbers in this array. So I can make this array whatever I want. I can make it -10 to, with a spacing of 5 all the way to 10. So now it's -10, -5, 0, 5, 10. So I can make this array whatever I want. It's just the values, the numbers that I want num to be, one at a time. So first it's -10, then it's -5, then 0, then 5, then 10. Okay. Those are basic for loops and while loops, but I wanted to use them to illustrate essentially the idea of a loop. So let's get to something a little bit more complicated. So here it says prompt the user to enter in the desired shipping option, ground, express, or overnight. Write a loop that forces the user to enter in an appropriate option. So here I have the keyword prompt. Prompt means I'm going to use the input function. Woohoo! So I am going to ask the user to enter in ground, express, or overnight, whatever they want, and then write a loop that forces the user to enter in an appropriate option. Okay, so I'm writing the loop that makes sure that the user enters in one of these options. This is called a user validation loop. Similar to what we did last week in one of our if statement examples that checks to see if the user entered in the right thing. Okay, so first thing first, I'm going to use the input function. Shipping option. And I'm expecting text, so I'm going to use my S option. Okay, so I've prompted the user. My loop, the goal of my loop, the purpose of my loop is to repeatedly ask the user to enter in something in until it's appropriate. So this is essentially what I'm going to repeat. I'm going to repeatedly ask the user to enter in something until it's correct. So I'm going to use a while loop to do that. And the reason is because I don't know how many times it's going to take the user to enter this incorrectly. I don't know if it's going to take them 1 time, if it's going to take them 10 times, 20 times, 3 times. I don't know how many times this is going to be required. So I'm going to use a while loop because I don't know how many times. Typically, we use a for loop when we know exactly which values we want our variable to be. I don't know, like there's nothing that tells me that opt is going to be exactly these values. So I don't know how many times it's going to take the user to do this, so I'm going to use a while loop. Okay, so I know the purpose of my loop. I know what I'm going to repeat. So now I need my 3 things. I need my initialization, I need my testing, and I need my modification. So I'm going to start with my testing. I'm going to start with my determining when my loop is going to end. Okay, I want my loop to stop. I want to stop asking the user when they enter in a correct option. When one of these, when one of these is entered in. That's when I want to stop. So now I'm going to write my conditional in order to do that. So I'm going to stop whenever my option is equal to ground, or my option is equal to express, or my option is equal to overnight. So there's my stopping condition. I want to stop when my answer, when whatever the user enters in is either ground, express, or overnight. So now I need to invert that. I need to figure out when I want to continue. So what I need to do is I need to, if I want this to be true, to stop, I'm going to make it not true to continue. So if it's not ground, if it's not express, if it's not overnight. And then to invert ors, I just do ands. So if it's not equal to ground or not, and not equal to express and not equal to overnight, that's when I'm going to stop. Or that's when I want to continue. So identifying when you want to stop, when are you done, repeating your loop, and then inverting that. So I want to stop when option is equal to ground, or express, or overnight. Which means I want to continue if it's not equal to ground, and not equal to express, and not equal to overnight. This is probably one of the hardest parts about identifying about writing a while loop, is what is your stopping condition? What is your continuing condition? So when do you want to continue, and when do you want to stop? Those should be inverses of each other. So I'll type this in, string compare, opt, ground, and not string compare, opt, express, and not string compare, opt, overnight. Okay, music. Okay, so that is when I want to continue. When it's not equal to any of those valid options. So that's my third thing. That's my figuring out when I'm testing my loop control variable. Okay, so notice I did this first because I wanted to highlight how we can identify what our loop control variable is. So if you look at this conditional, it all depends on what opt is. So that means opt is our loop control variable. It's essentially the variable that identifies when we are going to, the variable that identifies what controls our loop. What determines when we will stop, when we want to keep going. So DM kata, you would have to do this all in one. Or you would have to do this all in 3 parts. Because when we're using while loops, it's got to be one single answer. It's got to be either true or false. You can't have an array of answers. This is one way to do it. You could do it in more than one string or in more than one line of code. So you could test separately. And then create one variable that contains that single true or false. But I'm not going to show you how to do that right now. So Ben 11, string compare, if we go over to help string compare. So string compare compares strings or character vectors, so it's single quote strings. And it compares string 1 and string 2 and returns a logical true or false. So it answers true, they're correct, or they are equal, or false if they're not equal. So it's essentially saying, is opt equal to ground? Is opt equal to express? Is opt equal to overnight? That's what string compare does. We have to use string compare for single quote strings because they're just arrays of characters. So they're essentially arrays. Okay, so opt is our loop control variable. That means opt needs to be initialized and modified as well as tested. So initialized, you can initialize opt to whatever you want. I could initialize it to nothing. And just say, I'm just initializing opt so that it's none of these options and it's going to enter my loop in at least once. That's one way to do it. Another way to do it is we could just ask the user before our loop what their option is. So I just say opt equals ask the user. If it's incorrect, then I'm going to repeatedly ask them. If not, I don't need to. Okay, I'm going to leave it in this way. Okay, so now let's step through this code. So opt. Input the shipping option. Let's say the user entered in ground. The user entered in ground. So now if I look at this whole conditional, this is going to be false because it is equal to ground. So it's not equal to ground. This is going to be true. And this is going to be true. So false and true is going to be false. So this whole thing is going to be false, which means I don't even need to go inside of my loop because my user entered in the correct option on the first try. So here's an example of, depending on what the user enters in, if it's correct, it doesn't even need to go inside the while loop. So let's run it again. Let's say the user enters in, let's say they mistyped ground. So now opt is a misspelling of ground, which makes this true, this one true, and this one true, which means that the whole thing is true. So true and true and true gives me true, which means it's going to re-ask the user. So now I'm asking for the option again. Let's say they spell ground incorrectly again. It's gonna go back up, recheck this, which is still gonna be true, because it's not equal to ground, it's not equal to express, and it's not equal to overnight. It's gonna re-ask the user, and let's say the user finally realizes that they typed ground incorrectly. So it goes back up, it checks, now it is equal to ground, so this whole thing is false, and then it exits. Size opt2 equals 6 or 7 or 9. So Mitchell, that's a good, that's not exactly how you would have to write that in 3 separate statements. You'd have to say, is the size of opt, equal to 6, or size of opt equal to 7, or size of opt equal to 9. But that only works, yeah, string compare is case sensitive. If you want insensitive, just use the I, string compare I. That's for case insensitive. So doesn't matter for case. So back to your point, Mitchell, that would only work, like it would still work if you had if you typed in something that was 6 letters, like A, B, C, D, E, F. Yeah, A, B, C, D, E, F would technically work because it's also 6 letters or 6 characters. So you really need to compare it to ground. What you could do is you could, after class, I can show you guys how to do this with one option if you want. Okay, one other thing to note about loops like this is notice this is a pretty complicated conditional. So try something and test it. Let's say you inserted ors in here on accident. Not on accident, because you thought you needed them. So if we had ors in here, run it, see what happens. Enter in some garbage, enter in something correct. So ground, ooh, that didn't stop it. Express, oh, that didn't stop it. Overnight, that didn't stop it either. Why isn't it stopping? If you ever want to stop something, Control C, go back, change it. Let's say, okay, so maybe I did want an and. Then go test it again. Enter in some garbage. Okay, so it's working. It's asking if it's invalid. Let's check to see if it asks, if it continues, if it's valid. Okay, so here it stops. So it's behaving the way you expect it to behave. So with loops, it's a little bit more complicated. Use your debugger. Go through line by line. See what's happening. How are your variables changing? Test it. Does it behave the way you want it to behave? Okay, so there's that one. This one's a little bit more complicated because opt is our loop control variable. It's not modified. I do want to point out it's modified here. This is our modification. It's not a separate line of modification. Our modification is the code block, is the code inside of the loop. So this one's a little bit more complicated, but this is called a user validation loop. You will use it for your project. Okay, let's get to another example. So let me clear all this. Okay, so this example is a little bit more practical. It's a calculation versus the first two were just examples for the sake of examples, and this one is practical, but not necessarily in terms of calculations. So here it says the following describes an algorithm to calculate the cube root of a number. So the cube root of p. So essentially if we did nth root p comma 3. So here are the steps that are essentially occurring in order to do this calculation. So here's my steps. 1, choose an initial guess. R1 equals P. R1 equals whatever is under my cube root. And then I'm going to calculate a new guess as Ri plus 1. So R2. My second guess is going to be my first guess with this calculation. And then my third guess would be the same thing, but now instead of with R1, it'd be with R2, and then R3, etc. So I'm going to go ahead and do that. So let's say P equals 27. Cube root of P, the cube root of 27 is 3, so it's a known answer. So here we go. I'm just going to go through the steps. R1 equals P. There's my first guess. Then R2 is going to be calculated as R1 times R1 cubed plus 2 times P divided by 2 times R1 cubed plus P. There we go. That's my second guess. My third guess, so R3, is essentially going to be the same thing. But now instead of using R1, I'm going to use R2. My fourth guess is going to be the same thing, except using R3 for my calculation. So notice R5. I'm repeating the same code. And changing the same variables. I'm changing R1, R2, R3, R4, R1, 2, 3, 4, 1, 2, 3, 4. Let me print out my results. Notice I'm pretty annoying to do this. Not gonna lie. Okay, so let's print out the results. So my first guess is 13.53. Not quite 3. My second guess is 6.87. Still not there. 3.85, 3.03. I'm getting closer. So let's do a couple more. So R6 is gonna be R6 with now R5 as my calculations. And then printing out R6. So let me see, I'll see at the top. Okay. So now guess 1 is 13.53, then 6.87, then 3.85, 3.03, and 3.0. Okay, so I'm pretty much there. I've gotten to 3. Let me do one more. So R7 calculated with R6, print out R7. So I'm repeating 3. I'm getting to 3. Notice though, I'm repeating the same thing over and over and over and over and over again. So we've done this. There's also this thing here, calculate the error between two guesses as the absolute value of Ri plus 1 minus Ri over I. So I'm going to do that as well. So I'm going to say that my error, my E2, is going to be the absolute value of E2 minus E1 divided by E1. So there's my error calculation. I'm going to print out my error as well. Error point. I'm going to print out 10 digits past the decimal point for the error, just because I'm expecting it to be relatively small. E2. Okay. Once again, I'm copying and pasting to repeat the same thing over and over and over again in a repeatable manner. So I know for E3, I'm always going to be using E3 compared to E2. And I'm printing R3 and E3. For E4, I'm going to be using E3 or E4 compared to E3. And then E5, I'm comparing E5 to E4. So notice I'm changing the same variables every single time. They might have different names, but it's the same locations. So let me finish up with E6. And then I'll just delete E7 because I'm tired of typing the same thing over and over again. Okay, so let me fix my error. There is no, what did I? You gotta be kidding. These should be R values. Let me recalculate these. This is why we need loops. Less copying and pasting for loops. Okay, there we go. Another thing to change. Okay, there we go. I did it. Woohoo! Okay, so here we go. We have my guess. Here's my guesses, and now here we have this error, which tells me how far I'm off from essentially making a really small change in my guess. So for this one, I've reduced my guess by about 50%. For this one, between these two numbers, it's also a 50% difference. These ones, it's almost a 44% difference. These ones, it's only a 20% difference, but these ones, it's a 0.9% difference. So the error is just telling me how close am I to my guess being very small in change. Okay, but notice I got to 3 after 5 guesses for P. What if P was 125? 125, the cube root is 5. I didn't quite get to 5 for P equals 125. So I would need to add more guesses. What if P was 8,000? 8,000 should be 200. I'm even farther from my guess, or from my right answer after 5 guesses. But notice I'm repeating the same thing over and over and over and over and over again. That means that we can do this process in a loop. Okay, so I'm gonna start with a for loop. So for, I have 6 guesses here technically, but I've really repeated my calculations 5 times. So for count equals 1 to 5. I'm just saying that I want to do something 5 times. What I repeated in here were these calculations. I repeated those calculations. I calculated R and I calculated E, and then fprintf. So what is the code that you are repeating? These calculations. Now I just need to change my variables. So instead of it being R1, I'm going to say Ri. Instead of it being R2, I'm going to use Ri plus 1. And instead of it being E2, I'm just going to do E. And I'm going to print out Ri, I plus 1. And I'm calling those Ri and Ri plus 1 because that's what shows up in my calculations. So remember, your job as a programmer is to take your math calculations and write them in terms of in code. So I just decided Ri plus 1, I'm going to call it RIP1. And then Ri as well, I'm going to call it Ri. So now, here's my calculations that I'm repeating over and over again. Now I just need to identify some minor things to fill in. Notice I have Ri. I need to start Ri at a specific number. So Ri, my initial value, the first time I have my guess, is going to be P. So I'm just going to start Ri as P, just like I did here. Instead of calling it R1, though, I'm calling it Ri. So that means the first time I go inside this loop, Ri is going to be P. It calculates Ri plus 1, calculates E, prints those out. Okay, so let me run this. And here we go. So Ri is P. P was equal to 8,000. And notice my guess never changed. My guess never changed, so my error never changed. So the last thing I need to do inside of this loop is I need to make sure that Ri isn't always going to be P. I just need to make sure that Ri is going to be my previous guess. In this instance, I need to update Ri to be RIP1. Because that's essentially what I did up here. where R3 used R2, which was my previous guess. R4 used R3, which was my previous guess. It just so happens it looks different inside of a loop because my previous guess is the number that's previously calculated in my loop. And so here's the last piece. I just need to say that Ri starts out as P, I do my calculation, and now Ri is going to be updated to that most recent calculation. So now when I print it out, we can see here's my 5 guesses. In a loop, if I want to add more guesses, I just change my number. So now instead of count equals 1 to 5, I have count equals 1 to 10. And we can see here, after 10, I'm getting really close. I get to 20. There's probably numbers out here that I'm not seeing. I can expand this. So yeah, so it's not quite at exactly 20. Let's say I want to go to 15. So now here I'm at 15, and we can see I get 20 eventually. After 14, 12 guesses, I get to 20. If P was back to 27, same thing. I get to 3 after significantly less values, but we can see that 3 never changes. Same thing with 125. If I had a really big number, once again though, you can see here that after 15 guesses, I'm really close to my answer, but I'm not quite stable. I'm not quite to what it should be. So this is what it looks like with a for loop, where I just say, I want to do it for a specified number of times. Notice count isn't used inside of my loop. I never use my count variable. And sometimes that happens with a for loop where we don't really use our loop index variable. The only purpose is to make sure that it goes through 15 times. So here, it's just saying count equals 1 to 15. That's just ensuring that the code is going to be repeated that many number of times. Okay, so that is a for loop. Let's go ahead and see what it looks like as a while loop. So let me go back to the 125. So when I do 125, when I do 27, when I do 8,000, notice after so many guesses, my error goes to pretty much 0. So what I can say is I can redefine my loop to say that I want to keep calculating until my error is practically 0. So let's change it. Let me just copy and paste this down. Now instead of a for loop though, I want to do a while loop. So I'm just going to change my for to a while. And now I need to decide, okay, what is my loop control variable going to be? Sometimes it helps to think, what am I going to use in order to define when my loop stops, when my loop continues? So I know for this calculation, I want to stop when my error is practically 0, is pretty much a really small number. So that means I want it to continue when my error is greater than a really small number. So error is greater than 10e to the negative 10. Let's just choose 10 to the negative 10. That's just a really small number. So there you go. That's my stopping condition, which means this is my continuation condition. While my error is greater than a really small number, keep doing my calculations. So as soon as my error is less than that really small number, then I'm done. So that means e here is my loop control variable. So I'm just going to initialize e to something because I need it initialized. In this instance, it doesn't matter what you initialize e to as long as it's greater than this number. So I'll initialize it to 1. And then I need to make sure my error is updated. So it's modified here. So here's my modification. Here's my testing. And here's my initialization. So now, instead of my code continuing for 15 times automatically, it's going to stop whenever my error is really small. So here we go. So for 125, it stops after 1, 2, 3, 4, 5, 6, 7, 8 iterations. For 27, it stops after 1, 2, 3, 4, 5, 6, 7 iterations. For 8,000, it stops after 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 iterations. So it stops whenever my error is really small. For some really big number, it stops after 1, 2, 3, it stops after this many iterations. There's a lot more. But I eventually get there. Okay. So we went through different kinds of loops, while loops, for loops. We saw different examples. I will go over more examples on Wednesday. Like I said, for your exam, focus on understanding this material. This is your last set of real complicated material. You still have plotting. Plotting, it's just using plot functions. It's not as complex. So make sure you guys understand this material. Focus on your homework, this homework and next homework, because these are really key concepts. You need to know how to do this stuff for your exam and also for your project. So make sure you're focusing on this. If you want to study for your exam, maybe go back over, do some challenge activities, read through the notes. They're a little bit more theoretical, but hopefully you understand the concepts a little bit better. But yeah. Okay. Any final questions before we head out? For problem 3, that one is the, remind me, what is it on? What's the problem? I can't remember. Problem 2 is the shipping. What's problem 3? I feel like... Right, okay. So for that one, use a switch statement. I knew that. Use a switch statement. So we want, for that one, it's easier to use a switch statement because we are testing for equality. We're testing to see if the input is equal to CO2, if it's equal to CH4, whatever those are. So it's easy to use a switch statement because we're testing for equality every single time. How do you make a logical array into a numerical array in Zybook? Okay, so Cupcake Panda, you're talking about logical indexing. So let me... No, branching does not necessarily mean if else. Okay. So for logical indexing, let's say that we had an array or a vector of random numbers. Let's say I had this vector and I want to only grab the numbers greater than 0. Or the positive numbers. I could say A of 2, 3, 4, 5, 6, 7, 8, 9, 10. I could say A, 2, 8, 9, 10. And this will grab all the positive numbers. Well, I did that wrong. It will grab all the positive numbers, but that's only if I know exactly what the array looks like or what the vector looks like. Or I could say A greater than or equal to 0. This is another way that I can, and this is probably an easier way to understand logical indexing. This is another way I can just grab the numbers greater than 0. So if I do just this, A greater than or equal to 0, it gives me a logical array full of 1s and 0s, where it's a 0 wherever A is not greater than or equal to 0, and a 1 wherever it is. So if I do this, it's called logical indexing, where what it's going to do is it's going to grab all of the locations that correspond to true and delete all of the locations that correspond to false. So this is logical indexing, where we have an array, and then instead of saying specific locations, we have a logical array that contains 1s and 0s, where it's going to delete everywhere there's a 0 and keep everywhere there's a 1. For P2, can we use if statements within a switch statement? Sure. Yes. You want to definitely practice both if and switch. Sometimes, so for problem 2, you can't use a switch all the time, but you can use switch with ifs. They can go inside of each other. It's up to you. Absolutely. Any final questions? Okay. I'll see y'all on Wednesday. Have a great rest of the day. And enjoy lunch. At least that's what I'm going to do. Enjoy lunch.